Okay, the question: use divergence theorem to find the outward flux of the vector field capital F is equal to x cube I plus y cube j plus z cube k across the surface of the region that is enclosed by the hemisphere z is equal to square root of a square minus x square minus y square, and the plane z is equal to 0. Here the discussion is about hemisphere. So this is the hemisphere, and this is y-axis, and this is x-axis, and this is z-axis. This hemisphere is z is equal to plus root of a square minus x square minus y square. That means x square plus squaring this, we get z square is equal to a square minus x square minus y square. That is x square plus y square plus z square is equal to a square. Above the xy plane, that is sphere above the xy plane. So this is xy plane. So this sphere hemisphere vachirikkunnu evideyanu z is equal to 0 enna plane aanu, xy plane aanu hemisphere നെ കമഴ്ത്തി വെച്ചിരിക്കുന്നത്. അപ്പോൾ അവിടെയാണ് ഈ ക്വസ്റ്റ്യൻ നമുക്ക് ഡിസ്കസ് ചെയ്യാനുള്ളത്. Here we want to find the using divergence theorem. So divergence theorem is we have the divergence theorem is double integral over sigma f dot n cap ds is equal to triple integral over g div of dz dy dx. This is equation number 1. That is left side double integral over sigma f dot n cap ds is the flux. So flux phi is equal to this. So we first evaluate div of. What is div of? Div of is L dot f. Del is I dou by dou x plus j dou by dou y plus k dou by dou z dot x cube I plus y cube j plus z cube k. So this is equal to dou by dou x of x cube plus dou by dou y of y cube plus dou by dou z of z cube. So this is equal to 3x square plus 3y square plus 3z square, taking 3z common. So div of is 3 times x square plus y square plus z square. So div of 3 into x square plus y square plus z square. Here we substitute div of first this, then integrate dz dy, integrate with respect to z, then with respect to y, and then with respect to x. So we substitute this in equation 1. Here we substitute in equation 1, we get, then equation 1 becomes flux phi is equal to triple integral div of is 3 into x square plus y square plus z square dz dy dx. Here integration along upper hemisphere x square plus y square plus z square is equal to a square. Upper hemisphere plus on the plus root upper hemisphere we use spherical coordinates to integrate. Here we use spherical coordinates for triple integral. Triple integration ചെയ്യാൻ വേണ്ടി spherical coordinates apply ചെയ്യും. Spherical coordinates എന്താണ്? We substitute. We using spherical coordinates. What are the substitutions? Spherical coordinates ആകുമ്പോൾ x in rho sin phi cos theta, x is equal to rho sin phi cos theta, y is equal to rho sin phi sin theta, z is equal to rho cos phi, and 0 less than or equal to rho less than or equal to, using spherical coordinates in x square plus y square plus z square is equal to a square. ഇവിടെ പ്ലസ് കൂട്ടേ ഉള്ള ക്വസ്റ്റ്യനിൽ നമ്മൾ മൊത്തത്തിൽ എടുക്കുമ്പോൾ റേഡിയസ് എ വരും അല്ലേ. അപ്പോൾ 0 less than or equal to rho less than or equal to a and 0 less than or equal to 5 less than or equal to, ശ്രദ്ധിക്കണം മുഴുവൻ സ്ഫിയർ കൊണ്ടാണെങ്കിൽ പൈ കൊടുത്തതിനെ ഇത് സെമി സ്ഫിയറേ ഉള്ളപ്പോൾ പൈ ബൈ 2 കൊടുക്കും. ആൻഡ് theta varies from 0 to 2 pi. 0 less than or equal to theta less than or equal to 2 pi. Also, we substitute dz dy dx is equal to, അവിടെ നമ്മൾ ആ ഫോർമുല പഠിച്ചിട്ടുണ്ടെന്നാണ് dz dy dx എന്ന് പറയുമ്പോൾ rho square sin phi d rho d phi d theta. So dz dy dx is rho square sin phi d rho d phi d theta. Here x is equal to rho sin phi cos theta, y is equal to rho sin phi sin theta, z is equal to rho cos phi. Then x square plus y square plus z square becomes rho square. So we substitute x square plus y square plus z square is equal to rho square here. dz dy dx as rho square sin phi d rho d phi d theta here, and limits of rho is 0 to a, and limits of phi is 0 to pi by 2, and limits of theta is 0 to 2 pi. Then this equation becomes, this is equation 2, then 2 becomes, then equation 2 becomes flux is equal to outward flux is equal to triple integral 3 into x square plus y square plus z square becomes rho square, dz dy dx becomes rho square sin phi d rho d phi d theta, and limits of rho is 0 to a, limits of phi is 0 to pi by 2, and limits of theta is 0 to 2 pi. So this is equal to integral 0 to 2 pi, integral 0 to pi by 2, integral 0 to a, 3 into rho raised to 4 sin phi d rho d phi d theta. Again, first we integrate with respect to rho. That time sin phi is 3 into sin phi is constant. So at the step now, is equal to 0 to 2 pi, 0 to pi by 2, 3 sin phi is constant. Integration of rho raised to 4 with respect to rho is rho raised to 5 by 5, rho raised to 5 by 5. Between the limits 0 to a and d rho d phi d theta is equal to 3 by, substituting rho a in terms of rho, so a raised to 5, 3 a raised to 5 by 5, 0 to 2 pi, 0 to pi by 2, sin phi d phi d theta. Sin phi d phi d theta. So this is equal to 3a raised to 5 by 5, 0 to 2 pi. Integration of sin by phi with respect to phi is minus cos phi, 0 to pi by 2 with respect to theta. So this is equal to 3a raised to 5 by 5, 0 to 2 pi. Substituting phi by 2 in terms of phi, that is minus cos phi by 2, minus of minus plus cos 0 d theta minus cos pi by 2 0, that is 3a raised to 5 by 5, then 0 to 2 pi, 0 plus 1, that is 1 into d theta. So this is equal to, this is equal to 3a raised to 5 by 5 into theta, 0 to 2 pi, so 6, that is 2 pi minus 0, 2 pi, 3a raised to 5 by 5 into 2 pi, 6 pi a raised to 5 by 5. This is the final answer. 6 pi a raised to 5 by 5.